Hi tuts. Then let us see the solutions which we faced in the go backend. Let us see the solutions in this part. So we have the faced problem in the earlier that whenever packets is sended, so it is assuming the even though next set of packets, the same set of packets assuming as a next set of packets. So that's why we are going to be provide a solution in this session. So let us see what it is. So to provide the solution, first we are going to be in the solution we need to adjust the window sizes. Here we need to adjust the window sizes of sender and window size of receiver, so that for the whatever we face the problems in the go backend, we are going to resolve by these adjustments. So let us see first what is the window size of the receiver. So first, suppose here we are setting always window size of the receiver as 1, means always the window size of receiver is always 1. So with that it never receive the out of order packets, means only window size is 1. Suppose current packet it is received as 0, then it is expecting the current packet plus 1, means it is expecting the packet sequence number as 1, that is which is it is going to receive next packet. First it is received 0, so it is expecting the next packet as 1. So if it is received sequence number as 1, then it will consume. Other than 1, if any packet it is received, it is going to be discard. If it is not, if that packet sequence number is not 1. So that's why always window size of receiver is 1. So this is the first point we have to be noted majorly. So window size of receiver is always 1 in go backend. This is the solution for receiving the in order packets. So this is the one case. Then we need to set the receiver window size we set it here. Then we need to set the window size of sender. This is the case A assume. Then if you take the case P, so here what we are doing is we are giving a formula. According to that we are going to set the window sizes of sender. So window size of sender plus window size of receiver, it should always less than or equal to assigned sequence numbers, total assigned sequence numbers. Suppose we have the total 8 sequence numbers. Suppose we have the 8 sequence numbers, assume that. So we already fixed the window size of the receiver. Suppose this is 1, this is less than or equal to. So this should be always 1, and this is either 7, it should not be 8. 8 plus 1, 9. 9 less than or equal to 8, it is not satisfying, so it should be less than or equal to 7. So it is taken as a window size as 7. So now assume that we have selected 7 as a window size of sender. So with this, is it going to be solve the problem which we faced earlier? So let us see. Sender, receiver, here window size is 7 and window size of receiver is 1. So these are the packets it is going to be transmit 0 to 6, sequence number 6. Now it is transmitted all the packets till this complete window it is transmitted 0 to 6. Now it is receiving one by one. then it is received the 6th packet. So earlier we faced one problem that if acknowledgement is lost, in that case after timeout sender is going to retransmit the current window, that is 0 to 7. But the problem at the receiver side is it is assuming this set of packets as a next window or the different data whatever it is received earlier, but actually it is the same data. So in this case, see, assume it is given acknowledgement, but acknowledgement as sequence number 7, but it is acknowledgement is lost. As usually after timeout it is going to retransmit the same set of packets 0 to 6. Due to the window size of receiver is 1, it is expecting the sequence number as 7, but among these set of packets no packet have the sequence number 7. So now it is assuming that because it already given acknowledgement already for all these packets, so now it is going to be assumed that earlier whatever it is given acknowledgement that may be lost. So that's why it is going to give acknowledgement as 7 now. Assume by this time this acknowledgement is received, then it is setting the next window as 7 0 1 2 3 like this. So in this way it is going to be solve the corrupted case. Packet is acknowledgement packet is, if it is lost, it is going to be solved by setting this formula. So with these two formulas all the problems whatever we faced in the go back and earlier discussion in the earlier video, it is going to be solved. Case A, setting the always in go back and we can remember always window size of receiver is always 1, and the second one is this should follow window size of sender and window size of receiver is less than or equal to total sequence numbers, assigned sequence numbers. Let us see some of the inferences from the above formula. Window size of sender, window size of receiver less than or equal to assigned sequence numbers. So available sequence numbers, assume that total available sequence numbers are 8, and as we said that window size of receiver is 1. So here the many possibilities are there. 7 may possible, then 6 may possible, 2 possible, 5 possible, 4, 3, 2, 1 is possible. So plus 1, plus 1. In all the cases receiver window size is always 1. So this is less than or equal to 8, this is less than or equal to 8. Means here one thing we have to observe is we can select window size of sender is 7, window size of receiver is 1, and this also we can select window size of sender is 6 and window size of receiver is 1, because all are satisfying. So this is you can take, we can take, this we can take, but this we should not take, because window size of 1, window size of sender is 1, window size of receiver is 1. This is nothing but stop and wait protocol, right? So in the stop and wait protocol we discussed that window size of sender is 1, window size of receiver is 1. So if you selected the window sizes as one for the both sender and receiver, this is nothing but stop and wait protocol. So once again you are going to face the problems whatever we face in stop and wait protocol. So that's why this is we are not going to be select. These are all the valid possible things. Of course this is possible, but it is not valid in the go back end. So this is the one of the thing we have to see. And then next suppose n is maximum available sequence number. N is maximum available sequence number. So in this case, window size of sender, window size of receiver is what? So by default we will always take this one. So we can select this one, but by default we are assuming that as a immediate number of this one. So in all the cases in the go back N, in all the cases receiver window size is always 1. Now N is the maximum available sequence number. Here 8 sequence numbers. Maximum available sequence numbers is here 8. So window size is 7. So like this, here also N is the maximum available sequence numbers. So that's why window size of sender is N minus 1. Then in the second case, if the same N is maximum sequence number, in this case what is the window size of sender, what is the window size of receiver? In all the cases window size of receiver is 1. A bit tricky among these two. Here N is the maximum available sequence numbers. Total sequence numbers are N. So if 1 you given to the receiver, the remaining things are for sender. So remaining were 1 minus 1. But here N itself is the maximum sequence number. Let us take this scenario. Here total sequence numbers are 8. So 0, 1, 2, 3, 4, 5, 6, 7. These are the total sequence numbers here. And here in the first case N is 8. In the second case maximum sequence number, here among these numbers maximum sequence number is 7. Here N is 7. So window size of this one is N minus 1. Total is 8. 8 minus 1 is N. So N is maximum sequence number is 7. So that's why N is the maximum sequence number. So window size of sender is N itself. Then in the third case, assume that K equal to number of bits. Number of bits we are using for sequence numbers. I suppose 2-bit sequence number we are using. 2-bit sequence number is total possible sequence numbers are 0, 0, 0, 1, 1, 0, 1, 1. So here 2 bits, here K equal to 2. So total possible sequence numbers are 4. This means 2 raised to 2. Total sequence numbers are 4. So same way we can derive sequence number for N. Receiver sequence number is always 1. And here in terms of K we have to say that 2 raised to K. 2 raised to, this is nothing but 2 raised to K. 2 raised to K is total sequence numbers. So one sequence number we have to be reduced. So 2 raised to K minus 1. So window size of sender is 2 raised to K minus 1. So in this way, by here in this case, here we introduced window sizes of sender and receiver, and we set it always receiver window size is 1, and by using this formula, window size of sender plus window size of receiver always should be less than or equal to the available sequence numbers. So with this, this is the full-fledged go back N, we can say. Then let us see the some of the problems on this go back N.